So far in this course, we have focused on how to build agentic AI systems, how agents use tools, call MCP servers, and even run local models to get work done. But once a system is built, a new challenge appears. How do we know how well it's actually performing? Complex agentic workflows have many steps, and it's rarely obvious where things are going wrong or how to improve them. That's where evals or evaluations come in. Evals give us a structured way to test agentic workflows, measure their behavior, and track improvements over time. In this video, we'll introduce the core emerging ideas behind evals, why they are essential for any serious agentic AI project, and how they help us systematically refine and improve these systems. When we build traditional software, we rely on deterministic tests. Given the same input, the program should always return the same output. With LLMs and agentic AI systems, this no longer holds. The same prompt can produce slightly different answers. Quality is often fuzzy rather than binary, and many of the important questions are subjective. Was this response helpful? Did the agent follow policy? Did it use tools correctly? Evals or evaluations are the set of practices and tools for dealing with this. An eval is a structured way of measuring and improving an AI system's behavior. We define what good means for a task, create datasets or scenarios, and then systematically score the model or agent against them. Sometimes this is done with simple code. For example, checking if a competitor name appears or if a date is in the right format. And sometimes with another model or a human acting as a judge for more qualitative criteria. So you can think of evals as the analog of testing for LLM-based systems, but adapted to non-deterministic, open-ended behavior. They combine practices like error analysis, matrix, LLM as judge scoring, and continuous monitoring into a feedback loop that helps us understand where an agent is failing and whether our changes are actually making it better. When we evaluate an agentic AI system, the first step is to be clear about what we are trying to measure. LLMs and agents don't behave deterministically, so quality is rarely a simple yes-no question. Instead, we look at different dimensions of behavior depending on the system's purpose. Here are some of the most common things evals measure. Accuracy. Did the model provide the correct information? Groundedness. Did it stay consistent with the data or tool outputs instead of making things up? Task success. Did the agent actually accomplish the user's intended goal, including calling the right tools? Policy or safety compliance. Did the system follow the rules and avoid restricted behavior? Helpfulness. Was the response clear, useful, and appropriate? Format correctness. For example, valid JSON, correct API call arguments, or the right output structure. These dimensions form the foundation of any evaluation strategy. Once we know which of these matter for our system, we can choose or design the right type of eval, whether it's simple code-based checks or more subjective scoring using another model or a human. Now that we have seen what we measure, the next question is how we measure it. In traditional software, tests are deterministic, but LLM systems require a wider toolbox. Modern evals combine several complementary techniques, each suited to different types of signals. Here are the most common evaluation methods. The first one is string checks, direct exact matching, useful when there is a single correct answer. For example, verifying a date, an ID, or a required keyword. Another one is semantic similarity, uses embeddings to compare meaning rather than wording. Ideal when outputs don't need a match exactly, but should be close to a reference answer. The next couple of ones are model as judges. So the first one is a score grader. A separate LLM assigns a numeric score like 1 to 10 based on criteria like helpfulness or clarity useful for subjective qualities. The next model as judge is called label grader. Instead of a score, the model picks this category like correct, incorrect, too verbose, unsafe. Great for classification style judgments. The next set are programmatic checks like Python execution. Custom code verifies structural or factual properties such as did the answer include 3 bullet points? Is the date in the future? Is the JSON valid? These are some examples that could be checked with programmatic checks. In practice, real evals combines several of these methods using the simplest possible technique for each property. This allows us to build robust, repeatable tests even for complex, non-deterministic LLM behavior. To make evals concrete, let's walk through a simple example, a laptop recommendation agent. The idea is straightforward. A user describes what they need, their budget, a preferred operating system, and important technical requirements like RAM, storage, or CPU performance. The agent then checks a catalog of available laptops and suggests the best option, with a brief explanation of why it fits the request. The scenario is ideal for illustrating evals because it captures the type of everyday reasoning agentic AI systems must perform. Interpreting user intent, working with structured data, and producing clear, useful recommendations. We'll use this example to show how evals help us measure whether the agent is doing this job correctly and how we can systematically improve it. Now that we understand the laptop recommendation scenario, let's break down what we actually want to evaluate. Even for a simple task like recommending a laptop, the agent's output can fail in many different ways. So we define a small set of evaluation targets, clear criteria that describe what good looks like. For this scenario, typical evaluation targets could include accuracy, for example. Did the agent correctly restate or use the user's requirements? Groundedness. Are the recommendations supported by the provided dataset or tool output without hallucinating non-existent models? Task success. Did the model actually recommend suitable laptops that match the constraints? Safety or policy compliance. Did it avoid giving advice it shouldn't, such as unsupported claims or misinformation? Helpfulness. Is the explanation clear and useful to a non-expert user? Format correctness. Did it return the results in the expected format, such as a list or a JSON structure? These evaluation targets give us a concrete definition of success. Now let's look at how each evaluation question can be measured in practice. First, to verify that the requirements were understood correctly, we can extract the user's constraints with an LLM and check them against the recommendations using programmatic matching. Second, to ensure the answer is based on real data, we can compare the model's claims with the retrieved dataset using semantic similarity to catch unsupported or invented details. Third, to confirm the task was actually solved, we can apply a label grader, an LLM with a clear pass-fail rubric to judge whether the recommendations satisfy the constraints. Fourth, To check safety and policy compliance, we can run the output through a policy-aware label grader that flags unsafe or out-of-policy statements. Fifth, to measure helpfulness, we can use a score grader to rate how clear and useful the explanation is from a user's perspective. And finally, to validate the format, we can use programmatic checks to confirm the response follows the required structure, such as a correct list or valid JSON. In this video, we introduced the core ideas behind evals and why they are essential for building reliable agentic AI systems. We looked at how traditional deterministic tests don't work for LLMs and why we need structured evaluation methods that handle ambiguity and non-deterministic behavior. We explored a concrete example, a laptop recommendation agent, and showed how to define the key questions we want to evaluate. Then we walked through how each question can be measured using practical evaluation methods such as programmatic checks, semantic similarity, LLM as judge scoring, and policy graders. The big takeaway is that evals give us a repeatable, data-driven way to understand how our agent behaves, catch failures early, and improve the system with confidence. As agentic AI systems grow more complex, effective evals become one of the most important tools for keeping them accurate, safe, and useful.